Hello students, welcome to this amazing online learning. Today I'm so delighted to be with you, and before we proceed I would like to remind you of our normal routine. That's being at the right place, free of noises and distraction, and make sure you are with your notebook, your pen, as well as your textbook. Okay, last week we did something on force. We divided it into two classes because some are voluminous. So we did the part 1 in the former class, and today we're going to proceed with the part 2 under the topic force. And as you all know, my name is Miss Oyelami Janet Yetunde. Enjoy your class. So for today, we're going to talk about the objectives. Those are the things you ought to know at the end of this class. You must be able to state the differences between magnetic and gravitational force. Okay? Then you must be able to explain balanced force as well as unbalanced force. And you must be able to define friction. You must be able to list or highlight all its advantages, disadvantages, and uses. Okay, so let's get started. So we start today lesson. Last week we were able to know the meaning of gravitational force, and we were able to know the meaning of magnetic force. So today we're going to talk about their differences. This column stands for gravitational force, while this is for magnetic force. So the first one on my list says it is always attractive. That means gravitational force is always attractive. And on the magnetic force, it is always attractive and repulsive. Remember, like pole attract while unlike pole repel. When sometimes you put two magnets together, they don't tend to attract each other. That means maybe you are putting the north pole and the north pole together, so they will repel each other. But if you put the north pole and the south pole together, there will be attraction. So that's number one. Number two, it pulls both magnetic and non-magnetic objects. Okay, that means gravitational force is the force of gravity, so it has effect on anything, either magnetic or non-magnetic. And for magnetic force, it pulls only magnetic objects. Okay, and the third one, under gravitational force, it does not change with time, while for magnetic force, it's highly time dependent. That means it changes with time. Okay, the fourth one, no material is required to exert the force. That means it needs no medium. Okay, so far you are on the planet Earth, there's this gravitational force that acts on any object, any body whatsoever. So on the magnetic force, a magnet requires material to exert the force. Then the fifth one, it is a weak force field. Weak force field in the sense that is not having a small neighboring point that it covers, just like you have a magnetic force. It covers everywhere, so it could be a weak one. So it is stronger for it is a stronger force field. That means it's stronger when the magnet and the magnetic material that the magnets can attract are within the vicinity of force field. Is very strong. So the sixth one, it acts through long distances. That's for gravitational force. And for magnetic force, it acts through short distances. Okay, so our class activities. The first class activity we are going to look at, I'm going to give you how it's being done. So you're going to give me your answers. And before I finish this class, I would like to talk about the last class activity because I received a lot of responses from many of you. So step 1, under this very one, you have to place a bar magnet on your table. Just get a table in your house, place a bar magnet there. Then step 2, place a feather. You know, feather from either bird or from domestic chicken or whatever. Just get a feather. So, or key you use in opening your door, plastic cup, piece of clothes, and an aluminium plate. A short distance from, you have to place all these things, place them one by one, a short distance from that bar magnet you put on the table. You know, we talk about there's a force field around the magnet. You don't need to put it on the magnet, really. Just let it be a bit closer within the neighboring distance that you feel it can attract it. Okay, so the third step says observe what happened in each case. You place feather in the force field of the magnet, see if it will attract. Put key there in that magnetic field area. Then same thing, take them one after the other. So you observe what happened and write them down in each case. So the step 4, which of the objects is attracted to bar magnet? From your observation now, which one do you think is attracted to that bar magnet out of all of them? List them. So then step 5 says classify these objects into magnetic and non-magnetic. Definitely those ones that got attracted to the bar magnet will be magnetic objects. That means they can be attracted to magnets. While the one that magnet doesn't has any effect on them, they are the one you classify under non-magnetic objects. So do that, and please, I would like to know your answer. So balanced and unbalanced forces. When force occur in pairs, the force, when you say something occur in pair, let me classify the try to throw more light on that. Okay, when you say something occur in pair, that means in two. Okay, you have in a situation where two things are there's force on two things at the same time. Okay, the forces may be equal or unequal. When two forces are equal and act at the same point in opposite direction, for instance, this is a point A now. This is a point A. So one object is acting from point A, okay, down here, and another object is acting from point A down here. You see? Can you see the difference? They are acting at the same point but in opposite. Sorry, that should be opposite, not same direction. Okay? So it is in opposite direction. That means this one is going this way and the other one is going that way. So when forces occur in pairs, the forces may be equal or unequal. When the two forces are equal and act at the same point in opposite direction, just like you have here, to each other, they are called balanced. Like this one now, maybe the distance from here to here is 10 meters, and distance from here to here is 10 meters. So definitely they are equal, and maybe their weights, this one is 10 Newton and this one is 10 Newton. Oh, sorry, 10 kilogram. We are talking of what am I saying? We are talking of weights. So weights will be what? That's mg, mass times gravity, okay? Their weight will be what, please? That will be in joules. So we have to clean this. You have to clean this, okay? For instance, the weight acting on each of them is 10. Okay? That means they are equal. Okay, because at any point in time, G is constant, right? Which is 10 meters per second, and they have same mass. Okay, so this is a typical example of a balanced forces. Okay, a balanced force is one in which the net force equals to 0. Okay, if you look at here now, you see, this is the force acting on this one, which is 50 Newton. The force acting on this second one too is 50 Newton. But this one is pointing down while this one is going up. They must be in opposite direction for them to cancel out. Okay, so for instance, maybe the mass of this lady is 5 times acceleration, center of gravity, which is 10, force due to gravity, which is 10 meters per second square. 10 times 5 will give you 50 Newton. Okay, and that 50 acting downward while 50 acting upward. So definitely the value cancel out. That means it has no effect. So the net force, if you deduct one from each other, will give you 0. That's what it's trying to tell you here. The net force equals to 0. And the second one, do you think there will be any motion? No, because nobody will pull each other. They are all equal. Both of them are equal. So that's the answer, no. Example, you see a 25 Newton person with 25 Newton force. This one has force of 25 Newton. This one has force of 25 Newton. They are pulling the rope. Who do you think will go first? They will just, from now till forever, nobody will win, because they are exerting same force, equal but opposite in direction. Okay, so this is another example of balanced force. Just like you have in your physics textbook, you put on your table, there's a force which the table exerts on that textbook, which is making it to stay on the table. Okay, and there's another force being exerted downward, which is gravity, which pulls the book downward. So when the one pulling it upward is equals to the one pulling it downward, you have a net force of 0. That's a balanced force. Same thing here. So you can see them. Same thing here. Equal force on both directions. Both of them are pushing the car. Do you think the car will move? No, the car will always stand still. Okay, so when you are swimming and you think you float, there is a force that is in motion. Then, you know, there's this force that tends to, is the force the water uses in acting on the body. Is called the buoyant force. It pushes up any object that is on water. And there's another force called gravitational force, which pulls down any objects. Okay, so when both of them are equal, you see the person staying on top of the water, as in floating. That's why floating can be done when you are swimming. Okay, so you look at same thing as a balanced force. And another point, if the effects of force on two bodies are not equal, the system therefore is not balanced. An unbalanced force is the one in which the net force is greater than 0. Okay, that is, the difference between the two opposite forces is more than 0. We'll see that in a bit. So this is unbalanced forces. Okay, you have series of unbalanced forces right here. And unbalanced force is one in which the net force is greater than 0. Okay, so one can always pull each other. Do you think there will be any motion? Yes, there will be. Example, okay, you have people, these two guys, as they are exerting force of 25 Newton, while 3 ladies there are exerting force of what? 40 Newton. Who do you think will pull each other? The one greater will pull them towards themselves. So that's the push and pull we are talking about. So same thing with balance. I try to give you an example of balance and unbalanced. 5-5, nobody is pushing anyone. That's a balanced force. Then when you have 5-10, the one with greater force will pull the other one in that direction. Okay, So that's why in series of questions I asked you in the previous class, I said dash makes a stationary body to move. Is a force that can make you move. You might not want to stand up from where you're sitting, but if someone pushes you, you have to get up from there, or you are standing, someone pushes you, you have to fall or you run. So that's kind of what I'm talking about. Force always makes a stationary body to move, or even if you are moving before, if force is being applied on you, it makes you accelerate. That's what it means. When you accelerate, that means the speed of which you are using before is being increased. When there's increase in your speed, the way you move, that's called acceleration. Okay, and this another subheading which is called friction. Friction is a force which opposes motion between two surfaces that are in contact with each other. It is an example of contact force. You know, contact force are forces that has to do with touching, physical touching, or having when the objects and the force are in contact with each other. So this is one of the examples. Okay, so friction enables moving vehicles to stop when their brakes are applied. Friction is less in a wet, slippery road. Okay, it's not as high when there's sun. Okay, so these are the advantages of friction. It can help us stop moving. It can help us stop moving vehicle. When you apply brake, the brake pad will hook the wheel, which will make the tire to stand still. So that's the friction between the floor, the road, and the tire that is acting that way. So friction helps the moving vehicle to stop. So the second one is that friction helps man to move steadily on the ground. It helps objects to remain steady on inclined surfaces. What do you mean by inclined surfaces? Surfaces that are not totally horizontal. Maybe you put a plank on a step now, you know, that is an inclined surface. It's not as straight and surface as it ought to be. So is with the help of friction we are walking. Okay, between our leg and the floor there is friction that helps us in doing that. And the third one, friction prevent the bicycle wheel from sliding off a wet road. The fourth one, it enables a nail to stay tightly in a hole when you are nailing a plank or the wall. So it's friction between the nail and the wall that helps the nail to stay tightly in a hole, and so hold two pieces of wood together, or hold two things that you are trying to mend together. And the fifth one says friction between brake pads and the wheel enable the brake to work. Okay, that's it. Then disadvantages of friction. The first one, it opposes motion. Friction acts in opposite direction. Okay, it opposes motion. The second one is that it produces heat. You know, in machines or engine, is the friction. You know, friction, that's the resistance for it not to work, is being exerted on that machine. So definitely it produces or generates more heat than necessary. So that's number two disadvantage, sorry. And the third one is that it produces noise in machines. Okay, friction produces noise in machine. Okay, the fourth one is that it makes engines to consume more fuel. Okay, because there will be more energy to overcome that friction. So more fuel is being consumed in the process. In other words, it reduces the efficiency of the machine, of the engines or machine, whichever way you want to put it. Because if you get to a stage, you'll be calculating efficiency of a machine, you realize that efficiency of a machine will never be 100% due to friction. Okay, the fifth one it causes wear and tear in moving parts of machine and engine. That's why they have to lubricate, they have to add grease or oil in some parts so the machine can be able to work very well. So this second activity that I'm giving you in the class, this is very simple. All you need to do is just rub your palms vigorously and continuously for about 5 minutes. Okay, stop and use one of the palms to touch your skin. So the first question I'm asking you now is, what do you feel? The second one is your palm warm or cold? Then the third one is what is responsible for this observation? You have to explain to me. I'm curious. I want to know more about it. Okay, so in conclusion, for how we've been doing all this while for 2 weeks, we talk about force, and force is that which changes the state of a body at rest or its movement in a particular direction. Okay, force can be classified into contact and non-contact forces. You can call non-contact force field too. So push, pull, and frictional forces are what? Frictional forces are examples of contact force. Why magnetic, gravitational, and electric? Oh, this is not really under our scheme of work, but something about electric field. You know, in any electric field is made up of positive and negative. It's made up of both positive and, I'm trying to do the illustration. It's made up of both positive and negative charge. Okay, so they attract each other. Just like if you rub a paper on a surface of maybe metal, you see the metal trying to move as if it's charging the iron. So it's made up of two different charge that can attract each other. Okay, those are the example of non-contact force. Okay, the next point is that forces occur in pair, just like we have imbalanced and unbalanced forces. Okay, and the unbalanced forces cause motion to occur. You know, since their net force is more than zero, it's between a greater force and lesser force. So when that happens, definitely one will pull the other one, so there will be motion. And motion is absent where balance force prevail. Okay, when you have balance force, that means the net force, the differences between two forces is zero. So there won't be what? There won't be motion. That's what it means. So motion is absent where balanced forces prevail between the two surfaces in contact with each other. So friction can be beneficial or disadvantageous. Okay, you can see that from what we've been saying. And the last one is that friction has been found useful in machines such as gear wheel, grinder, screw, generator, name it. You have so many machines and engine that without friction, it won't be possible for the machine to move or to work efficiently, although it affects its efficiency too. And as well, it helps us in you know, there was a question I asked during your class activities, that multi-choice question. I said something about why writing with chalk on the board you can't fall down due to what? I can't remember how I put that question, but the answer there is gravity. You know, there's difference between gravity. Don't mix it up. There's difference between gravity and friction, because I saw a lot of you pick friction. Friction is between two surfaces. If you read my question very well, I said it prevents, as a teacher now, I'm writing on a board I'm not falling down. I can stand straight because of force of gravity. You know, it's the force that pull me down onto the ground. Okay, it makes me to stand. It's not. I'm not talking of what makes me to write between my marker or my chalk and the board. That's a different thing. Okay, so over to the class activity of last week. Last week I asked you to roll an empty drum and horizontally and tell me what you see or observe. Okay, I saw some answer from some people, but I just feel I should try to explain better. You know, when you give the drum a push, it moves. And it can move. If you take off your hand, it can move for a while, then stop, because at least you push. That's the force that you apply there. And when you apply the force while the drum is rolling, number one, the kind of force you apply is called contact force, because you have to touch it. And another thing that you must note is that while the drum is rolling, if you notice, both the upper part and the lower part is a round shape. So as it's rolling, there's this centripetal force that is being observed there. That's the force that make ball to go in a circular motion. That's another thing you must note. And about the towel, you know, I said two people should hold a towel, a wet towel, and try to squeeze the water out. If both of you are squeezing it, provided you are applying the same force, you won't feel it. But as soon as one person is holding and the other one is trying to squeeze out water, definitely there will be motion, there will be movement, because you that you are not squeezing or you are not applying any force, you will feel the force of the other person. So those are the things I expected you to give me. You know, as a scientist, you have to think outside the box, think more than what you can see, just reason and look at how things can be done. So that's very simple, and it requires your intelligence. Okay, I know you are all intelligent. Okay, try to do this too, and I would like to see the feedback, get the feedback from you. Okay, stay happy and try to be happy always. Bye bye.